We need to do part B of that example. So let me go to the next page. We're going to do the range, the quartiles, and the IQR for the data in part B. Okay, so now what's nice here in part B, that data is already ordered for us, right? 62, 63, 64, 64, 70, 72, 76, 77, 81, 83. It's already given to us in order. That's really nice. So let's calculate the range. Hey, it's the highest minus the lowest, right? So the range, boom, knock it out. 83 minus 62 gives us a range of 21. Excellent. All right. Let's move on to the quartiles. Now to do this, I need to write out that data again. There's a reason why I'm giving two examples here in number 7, and it's because of just how to handle different situations with the median or with quartiles. So as I see these numbers, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that means to cut it in half, it's going to be 5 here and 5 here. So the median's going to fall right there in the middle. That's Q2 will equal 71, right? But now if there are 5 below and 5 above, how do we calculate Q1 and Q3? Well, okay, so down here in the lower half, again, kind of think of, right, marking them off. So mark one, kind of cross one off, cross one off, cross one off, cross one off, and Q1 is exactly 64. We land right on it. And in the upper part, Q3 is exactly 77. Okay, there we go. There's our quartiles: 64, 71, 77. Looking good so far. All we got to do now is the IQR, the interquartile range, the difference between Q3 and Q1. Well, once you have the quartiles figured out, 77 minus 64, the IQR here is 13. And now this data seems a lot more centered. The IQR is 13, okay, but then the range is only 21. So everything seems like more or less equally spread out amongst all of those data values. Okay. We're going to use this idea of the quartiles and the IQR and the range to develop another way to depict data. It's called the box plot. So the box plot is pretty cool. I really like it. It's a graph consisting of 2 lines to display the outer 50% of the data and 2 boxes to display the inner 50% of the data. And here's an example. So again, a survey coming from that same stats class. The first time I taught the class, I needed data. And so I asked everybody about how many hours of sleep. I think I asked them, how many hours of sleep did you get the previous night? That's what I said. How many hours of sleep did you get just the last night? And there's the data there. And so at the bottom, I'm listing the smallest data value, the quartiles, and the highest data value. So you see somebody in that class the previous night only got 2 hours of sleep. The highest data value was 10. Okay, oh, that's doing pretty well. And then you see all the quartiles there as well. And so the median would be 7. And then, okay. And now how do those, get displayed in what we call this box plot? So you notice that we draw these lines. So we've got a marking there at 2. And then the box begins at Q1, which is 6. We draw another line at Q2 at 7. We draw another line at Q3, being 8. And we draw another line at 10. And in the center, we create these boxes, while on the outer quarters, we just draw these lines. So the idea is it's to draw your eye to the middle 50%. So you can see, oh, okay, from 2 to 6, that's like the lower 25% of the data. And then from 6 to 7 is another 25% of the class. From 7 to 8 is another 25%. And from 8 to 10 is another 25%. So it's getting at how spread out is this data. Okay, we're going to create one of these on our own in practice number 8. Let's do it. So it says the number of meteorites found in 9 U.S. states are 89, 47, 164, 296, 30, 215, 138, 78, and 48. The number of meteorites found in 9 different U.S. states. We don't know what those states are or any more than this. Okay, let's construct a box plot for this data. Okay, let's do it. So the first thing we need to do, if we're going to find quartiles, is to put the data in order. And so here we go. 30 is the smallest, 296 is the biggest, and, well, I won't read them. There they are on the screen. Take a moment, write those out in order. Okay. Now, we don't really need to calculate the range to create the box plot. We can see the smallest is at 30, the biggest is at 296, but we do need to get those quartiles. So let's try that out. Okay, well, what's going to be in the middle? If we have 9 different points of data, then there should be 4 and 4, and so that puts 89 right at the center. So there's Q2. And now this gets interesting. If Q2 is 89, how do we go about figuring out Q1 and Q3? All right, this is actually something that's debated among statisticians. Some people prefer to do it one way, others another way. I'll tell you both, and then I'll tell you the way that I lean, but really there is no right or wrong, and you might decide to do it a different way. How are we going to get Q1? So some people would say you should only look at, you shouldn't look at 89, you should only look at these 4. So to get Q1, you should just look at these 4, and then we would draw Q1 right between 47 and 48. That's what some people would say. And in the same way, you'd need to be consistent, right, to do Q3. Then you would say, okay, ignore the 89, only look at these, so Q3 should land right here. Whatever is directly between 164 and 215. That should be Q3. I, on the other hand, think of it a different way. I think of it as, hey, if Q2 is 89, then I'm going to think of 89 as a part of this group, meaning 48 is Q1. So I'm thinking of all 5 of these, and so the center is 48. But then I'm also going to include 89 on this part to be consistent. So that would mean the center is 164. Again, there's no right or wrong here, but you do need to be consistent. Okay. So let's create our box plot. Well, how's this going to go? We need to indicate the lowest and the highest. Let's go ahead and do that. So I went ahead, and you see a box plot. It's only the lower portion there. There is that vertical line there on the left, but okay, I mean, that's we don't really need that, and sometimes you see it, sometimes you don't. You need that horizontal line. So I'm going to say, okay, if my lowest is 30 and highest is 296, I'm going to say 0 to 300 and then just mark 50s, all the way up. That looks pretty good. And so, okay, let me indicate where 30 is. Well, if that's 50, 30, I need to make a small mark about right there. The box plot hovers above the line. We don't draw the box plot directly on top. it's up above, okay? And then the highest is 296, so that's almost all the way to 300. And maybe let's do our quartiles. So I'm saying Q1 is 48. So that's 50. 48 is just a little bit short. Now this line I'm drawing is a little bit wider because that's going to be a box. And then 89. 89, still not all the way to 100. And then 164. Okay, there's 150, so it's a little bit past that. And then all the way up. Okay, and now what we do, we make a nice big box here at the middle. That's the middle 50%. And then we just draw these little lines here on the edge, and this one stretches out really far. And now when we do that, now this really shows the center, or the spread, I should say, of this data. And well, center is not too far off either, but it really highlights how spread out this data is. Now, most of the data is down here, but then we have these few states that are really high. I'd say these two really go quite. Even 164 is getting. There's a pretty big leap even there, and then there's these other big leaps. So some of these states have a lot more meteorites than their companions. So we really see this shooting up. So 25% of the data is packed in really tightly, and then we see another 25%, so that middle 50%, like you see it starting to spread upwards, and then that upper 25% is really spreading. These numbers are really spread out as you get up here. So more tightly packed and then more and more spread out as you go. Okay, we're going to stop that video, this video right here. This is a good breaking point. See you in the next one.